Previously, we talked about how to find square roots of just general square numbers like 25 and 36. We've talked about how to find square roots of what I call composite squares, where you have several or a couple squares that have been multiplied together. Like here we have um, 576. And really, this is a square itself. It's just such a large square that we're not familiar with it. So then we find it by breaking it into those composite squares, which we found out earlier was 4 and 144. We take the square root of those, and we get 2 times 12, which then is 24. And so we find out that the square root of 576 is 24. But sometimes you're going to have to take the square root of things that aren't perfect squares. And so we're going to talk about how to do that today with a few different numbers. Here we've got 250. So we're going to start the same way we did with the composite squares. We're going to try and break it into things where we can take a square root out. So hopefully you can see pretty easily that 250 can be divided by 25. Okay, and so what we'd have left then is 10. Now 25 has a square root, 10 does not. Now, Elements of Algebra goes through a whole discussion on how to find the fractional value of what's called an irrational root, being a number that doesn't have a perfect square root. An irrational number is one that it's a decimal number that can't be written as a direct fraction, like 1/2 can be written, or I'm sorry, 0.5 can be written as 1/2 and things like that. It doesn't have a direct fractional equivalent, and it never repeats. So it just goes on and on and on forever, like pi or e, although you guys probably don't know about e, but that's fine. Square roots are the other time that these irrational numbers come up when you're taking squares of things that are not perfect squares, things like 10. Okay, so what we're going to do here, instead of trying to figure out what's close but not too far, like we did in the last lesson, to figure out that our answer to the square root of 576 needed to be less than 25. Instead of doing that, we get to do this really fun thing where we just leave it as a square root. So we look at this. We broke 250 up into 25 times 10. 25 has a square root, so we take that out. 5 times the square root of 10. And that is our answer. Okay? We just leave it like that. We're good. All right, so let's do a few more. Okay, so we have, let's say, the square root. I'm trying to come up with ones that aren't on your homework. All right, let's find the square root of 27. Okay, so we know that 27, it comes from 9 and 3. Now 9 has a square root, but 3 does not. So we're going to take our square root of 9 and bring it outside the square root. So that's going to leave it as, that's going to get us our 3 on the outside. And then we're left with the square root of 3. Now the square root of 3, of course, does have a value. It's about 1.72, I believe. But that's not necessarily a number that you need to know in your head. At this point, it's kind of like pi. The only reason that people know that is to, win contests about how great their memory is. So if you find it amusing and want to memorize the square root of 3 or the square root of 2 or something like that, that's perfectly fine. However, for math class, leaving something as the square root is, 3 times the square root of 3, that's a perfectly acceptable answer. Obviously, since 3 is less than 4, it's going to be less than 2 because the square root of 4 is 2, right? So if there comes a time when we need to approximate this, it's about 1.7. But I don't foresee that happening. But again, you can just leave it as 3 square roots of 3. All right, so let's try another one. Let's do the square root of 32. So we can, again, we're going to break this into factors. We get 4 and 8. Now 4 is a square root, and so that's great. Or it's a perfect square. We're going to leave that for now. We're going to break 8. That gives us 4 and 2. So again, we've got 4 is a perfect square. We're going to leave that, and then we're left with 2. So we've got 2 4s, right? And then a 2. So we're going to be left with our square root of 2 inside. We could take 2 times 2, or we could just say, hey, there's, 4 squared inside here. So I'm just going to go ahead and write my 4 there right now. Of course, also 32 is also 16 times 2, so you could take it that way, but that's perfectly fine. So again, you're just going to be factoring whatever's inside your radical, whatever's inside your square root symbol, until you end up something like this. By the way, the square root of 2 is about 1.41. Often we come up with things like the square root of 2, square root of 3, square root of 5. Square root of 10 doesn't happen very much. But yeah, in general, you're going to be factoring out any perfect squares that you can, and you just leave the rest inside the square root sign.